Example 2. So this example is now based on the notes from earlier today or yesterday, and these are dealing with our shifts. So the idea is going to be very similar to example 1, but now we have some shifts. But the process again will be the same. So the first thing that you're going to do is you're going to plot the given information on our coordinate grid. So I'm going to plot my focus, which is at 3, 2. And I'm going to plot my directrix, which is the line y equals 0. Next, we're going to find the vertex. Now, the vertex is the point right in the middle between the directrix and the focus. So this is the point, that is my vertex. And again, you don't need to do this, but if it helps you, please do. We're going to just do a quick little sketch of our parabola just to figure out what the orientation that it opens. Wow, that's really rough for me to say. Okay, so it's going to open up vertically. So I'm going to go to my appropriate equation. So let's go up here. Again, I'm only going to do this once. So I said it was going to open vertically. So I'm specifically looking at this equation right here. So I'm going to grab that equation, 1 over 4p x minus h quantity squared equals y minus k. Now, we want to fill in a value for p, h, and k. So h and k is the location of the vertex. So our vertex, right, is right there. So our vertex is located at 3, 1. Whoops, finger painting. Next, excuse me. So the next thing we're going to do is we're going to look at our P. We're going to go find P. Now remember, P is the directed distance from the vertex to the focus, again from blue to red, which is a P equals 1. It's a distance of 1 positive unit. So at this point, we plug in all these numbers into our equation. So I get 1 over 4 times 1 times x minus 3 equals y minus 1, which cleans up to 1/4 x minus 3 squared equals y minus 1. Okay, at this point, it's time to graph it. Now I want to remind you, these are shifts. They're the location of the vertex, which we have already dealt with. In other words, what we're going to do is we're going to treat, just like we've done before in the past, is I'm going to treat that vertex as the origin of a new coordinate grid. So I'm going to draw a coordinate grid through my vertex. Now my vertex is the point 0, 0, and I'm going to treat it like 0, 0. And the nice thing is if I treat it like 0, 0, I can ignore these two numbers because they're dealt with. And the nice thing about that is then when I go to make my table, I can make my table for this function. It's the same function without the shifts. And we can make that table just like we did the other day. So, or should I say in the previous example, choosing 3 points. And again, I'm going to choose my normal 3 points. So I'm going to choose, whoops. I'm going to choose -4, 0, 4, which squaring those for our parent, we get this. Multiplying them by 1/4, I get this. Now, As long as you treat that vertex as the origin, then graphing this is really easy. Whoops, this was supposed to be a 4. Let me change that. So again, I'm treating my orange coordinates like that, like my new coordinate grid. So my first point is the origin, which is at 0, 0 of my new coordinate grid. That's my vertex. Then I'm going to graph 4, negative 4, 4, and 4, 4. So negative 4, 4, and 4, 4. So the parabola will look like this. So again, this isn't too much different than example 1. The only thing you have to do is you have to take care of your shifts. Once you've taken care of your shifts, that vertex, you're going to treat it like the origin, and go about making your graph. Let's move on to example B. What I want you to do right now is I want you to figure out which direction it's opening up. Choose the appropriate equation. Okay, so let's go and do that. So our focus is at negative 1, negative 1. So it is, I was going to do this in red. Negative 1, negative 1. And our directrix is at the vertical line x equals 5. So I think that's right here. I may have to double check. Let me double check really quickly. 1, 2, 3, 4, 5. Yep. Okay. Now I want to find the vertex. Now remember, the vertex is directly between those two. So it is right in between this point and this point right there. It's right in the middle between those two. You can always find the middle between two things by adding the two numbers together and dividing by 2. So for example, if you can't tell visually, like I visually can look at this and say, oh, okay, it's going to be right here. But if I couldn't, I could take my two numbers. So I could take negative 1, add it to 5, getting 4, divide it by 2, getting 2. So I could take the average. So I could do that. But again, in this case, I really don't need to do that. I can just kind of visually tell that the vertex is going to be right here. And doing that, I can see, right, that's going to look what my graph's going to look kind of like. So it's going to be horizontal. Since it's horizontal, it's going to be of the form 1 over 4p times y minus k, quantity squared, equals x minus h. At this time, what I want you to do is fill in the numbers for h, k, and p, and simplify your equation. Okay, so what you should have, so the vertex is located at 2, negative 1, and p is the directed distance from vertex to focus, so p equals negative 3. Plugging those values in, I get 1 over 4 times negative 3, which is negative 12. Then y minus k, so y minus a negative 1, which becomes y plus 1, equals x minus 2. Okay, at this point, what you should do is you can make your coordinate grid, you can make I'm going to call it a temporary coordinate grid going through the vertex and graph your function. Okay, so I'm going to make a coordinate grid going through my vertex so that my vertex is now located, I'm going to call it my origin, just for graphing purposes again. So let's see, going to make my table, and I'm going to use normal points because there's no reason not to. The only thing I have to be careful on here is, again, this is horizontal, so this will be y, this will be x, and this will be negative 1/12 x. So I'm going to choose my numbers, negative 4, 0, 4. Squaring those, I get 16, 0, 16. Multiplying them by negative 1/12, I get negative 4/3, 0, 4/3. So don't forget your points are going to be negative 4/3, negative 4, 0, 0, and 4/3. Whoops. Let's see, I'm kind of messing up here. So there's a negative there. So 4/3, 4. So graphing that, let's see. My point 0, 0, again, using the orange graph as my new graph, 0, 0. Then negative 4/3, negative 4. So that looks like maybe about there. And the other one's going to be in the opposite direction. 1, 2, 3, 4. So maybe there. That looks a little bit off, but hopefully it's right. The graph's going to look something like that. Okay. Let's move on. So what I want you to do is I want you to try number 5 on your own. When you're finished, restart the video. Okay, so for number 5, we're going to go and do our normal stuff. So the first thing I'm going to do is I'm going to plot my given focus. So my focus was at 5, negative 1. 1, 2, 3, 4, 5. Negative 1. And what else did we know? We knew the directrix is at x equals negative 3. 1, 2, 3. So it is the vertical line, x equals negative 3. So I'm going to find my vertex. My vertex, again, is that point that is directly in the middle between this point and that point. So let's see. So the distance between those two is 1, 2, 3, 4, 5, 6, 7, 8. So 4 away. 1, 2, 3, 4. That's my middle. Okay. So looking at this again, doing a quick little temporary graph, I can see it's going to open up like that. Ugh, that's terrible, but that's fine. So it's going to be a horizontal one. So the equation I'm going to use is going to be 1 over 4p y minus k, quantity squared, equals x minus h. Next, I'm going to plug in my specific values. So again, my vertex is located, looks like it's located at 1, negative 1. And p is positive 3. So plugging those in, I get 1 over 4 times positive 3, which is 12, times y minus a minus 1, which is plus 1, equals x minus 1. Actually, I made a small mistake, and I don't want p, if you look at it, is actually 4 units, so let me correct that. So p is 4. I counted wrong. So that's actually 1/16. Okay, so please make the appropriate changes. Making my table. Where am I going to do this? I think I have room right there. So it's horizontal, so it's going to be y, x, and 1/16 x. Choosing my normal numbers, negative 4, 0, 4. I get 16, 0, 16, which gives me 1, 0, 1. So plotting those points. Now remember, as always, I'm going to make a coordinate grid with the origin being my vertex my translated vertex. So when I go to plot my points, it's going to be 0, 0 right here. What do we have? 1, -4, 1, 2, 3, 4, and 1, +4, 1, 2, 3, 4. So our graph looks like that. Okay? At this point, stop the video and do the second one. So number 6. Okay, for number 6, let's see what we've got. So plotting my normal stuff, I have -2, 0. -2, 0 is right here. That's my focus. And then my directrix is the horizontal line y equals 4. 1, 2, 3, 4. So it is right here. My vertex is right in the middle between those two. So hopefully you agree that it looks like this. So again, my parabola is going to have to look like this. It's going to have to open down. So the equation that I am going to be choosing is going to be 1 over 4p x minus h quantity squared equals y minus k. So at this point, I'm going to plug in my values. So my vertex is located, it looks like it's located at, -2, 2. And the p-value is the directed distance from blue to red, which is -2. So plugging those in, I'm going to get 1 over 4 times -2, which is -1/8, times x minus a -2, which is +2, and y minus 2. Next, I'm going to make my coordinate grid that goes through my vertex. And I'll make a table. And I'm going to fit it as best I can right here. So since this is vertical, I can just go x, y, and -1/8 y. So -4, 0, 4, 16, 0, 16, -2, 0, -2. So plotting my points, I have 0, 0, -4, 2, 1, 2, 3, 4, -2, and 4, 2, 1, 2, 3, 4, 1, 2. So the graph, is that right? I guess so. It looks off, but I think I plotted in the right spot. So the graph looks like that. Okay, and that is the end of the video for example 2.